Full Stack Hiring Day. My name is Jenna, this is John, this is Alfonso, and this is Matt. And together we built BYODB, which stands for Build Your Own Database. So BYODB is a web app that lets non-technical users create, manage, and query their databases. We decided to work on that project because we wanted to make database management more accessible, and we thought it would be an interesting challenge for us to build such a tool. So as you can see on the screen, the basic functionality of our app is that you can create your databases, you can create your tables, set the number of columns, their type, you can filter your data, you can associate your tables, and you can cross-query those tables. So John is going to explain you how we actually built this app.
Great. So because of the nature of our app, one of the most important things to us was to find the best way to send, receive, and store all of our information that we kept in our databases. So we exclusively use SQLize in our master database, which is where we stored all of the metadata about our users and their corresponding databases. As you can see, when a user creates a new database, a request is sent that passes information first through the master database, where rows are created to keep track of this user in the newly created database. After this, a separate actual database is created that can only be accessed by the user. At this point, we moved away from SQLize because we realized it doesn't really provide the malleability that our app requires. So, for example, it can't easily add or delete columns from an existing table. So instead, we decided to work with Connects, which is a library that essentially simplifies query building in JavaScript. We use this for the majority of our operations in our individual databases. But Connects itself has its own limitations, whether it's deleting an entire database or querying multiple tables at once. And in these instances, we simply created raw SQL queries using Postgres, but this was about only 20% of the time. So to expand on some of the functionality of our app, Alfonso is going to take you through associations.
Thank you, John. One of the main advantages of creating a relational database is actually being able to set associations between the tables. So to do that, a user simply just picks two tables and then is prompted to set either a has one or a has many relationship, both ways. In order to keep track of these associations, we decided that upon database creation, an association table is also created in the backend that we use to manage these relationships. We also use this table to render the relationships on the front end for the user to see. So for example, if you had a sports league database and you had a table of teams and players, and you wanted to say players had one team, it would create a column on the players table referencing primary keys on the team table, and referencing primary keys on the team table. If you wanted to say a team has many players, this would actually render a virtual column on the teams table, and with links that would redirect the user to a team filtered by players filtered by that specific team. When you set a has many relationship both ways, this actually creates a join table in the backend. This join table will reference the primary keys on both of the respective tables. We also will use this table to query, which Matt is going to talk to you guys a little bit more about.
Thanks, Alfonso. So once a relationship is set, we want to allow users not only to query a single table, but query across relationships. For example, if a user says that there's a relationship between teams and players, we want to show the relevant team data whenever they're searching for a player. Of course, we don't want our users to have to write raw SQL queries because they can become very complex very quickly. Instead, what we did is we built an intuitive GUI that still maintains the power and flexibility of traditional querying, but removes the burden of having to write a complex series of commands in order to retrieve the proper data. So while this allows for a much more intuitive user interface, it presented some challenges for us on our backend due to the sheer number of possible combinations that can be created when setting a relationship. In order to manage this, what we did is we created a series of logic that queries our master associations table and pulls relevant data such as the type of relationship, the direction of that relationship, and the column alias for each table in that relationship. The result of that function is a series of request parameters that we use in our express routes that makes the request for the proper data, which is then rendered on our front end and is always accurate and up to date. So that was a quick introduction into BYODB. We open the floor for any questions that you guys might have.